Okay, so this video we're going to go through intro to differential equations. You guys can check out Cognity if you want, but this is all I'm going to go through or expect for you on the final. So I'll go through 3 examples with you, and then for your homework I want you to do number 4 through 7 like it says up here, and then upload photos of your work to Google Classroom. So this first kind we've already done before. Basically, a differential equation is just an equation with a derivative in it. And so right here, this part is the derivative. And so it's like working backwards. If we know the derivative is 9x squared plus 6x plus 4, then we're trying to solve this equation for y. So find y. And so there is something called the general solution and then also a particular solution. And so general solution would involve the constant c, and particular solution we can solve for c. So this one, I'm going to be technical about this, and if we want to get this y by itself, what we have to do is first multiply both sides by dx. So think of this as a fraction with differential equations. And so when we multiply both sides by dx, we can write it like this, where we put the whole thing in parentheses and then we multiply by dx at the end. And now, in order to solve for y, we must integrate both sides. So then we put our integral in front. And so the integral with respect to y is just y. And you could say, I mean, really technically we should have y plus c here, because I could add any constant. And then the same thing on the other side. I need to find the antiderivative of this function. So 9x squared, that would be 9 times 1/3 x cubed, or 3x cubed, plus 6 times 1/2 x squared, so that'd be 3x squared, and then plus 4x, and then plus any constant c. Okay, so we can check this by taking the derivative. 3 times 3 is 9. Drop the power by 1, we get 9x squared. Same with this, 3 times 2 is 6. Drop the power by 1, and the derivative of 4x is just 4. So now if we're going to solve this for y, we subtract c on both sides. Subtract c. And now is where it's kind of theoretical and weird. If I subtract any constant on both sides, it doesn't necessarily cancel out, because that constant on the left could be different from the constant on the right. So we still have some number over here, some constant. And now we have to solve for that number by using this initial condition up here. Why, when they use this notation for differential equations for some reason, it just means f of 1, but right, we're not using f anymore because of the integral notation. We're using y. So y of 1 just means when you plug in 1 for x, y equals 2. So plug in 1 for x and we get 1 cubed is just 1 times 3, and then 1 squared is just 1 plus 3 again, and then 1 times 4 is just 4. And solve for c, and so we get this is 10. So 2 equals 10 plus some constant, and we subtract 10 on both sides and we get the constant equals -8. So now we can write out our solution, which is a function 9x squared plus 6x. Oops, what am I doing? I'm writing down the wrong thing. That is not our answer. That was this other function. Our final answer is down here, and we're just plugging in the c now. So 3x cubed plus 3x squared plus 4x minus 8. And that is our solution. This function will have a derivative of 9x squared plus 6x plus 4. And we're done. Okay, the next one is going to be a little bit harder because we've got x's and y's in our derivative. So we're saying that the derivative of y with respect to x equals x over y. So we still need to solve this for y and find the general solution first and then the particular solution. And so what we have to do first is called separating the variables. And so if we multiply both sides by dx first, we would get something like this, x over y times dx. And now we want to get the y on the other side. So we just have to multiply both sides by y. So we have y times dy, and we have x times dx. Okay, and now to solve for y and get rid of the dy and the dx, we integrate both sides. Okay, and now we have to find the antiderivative of both sides. So antiderivative of y is 1/2 y squared. Oops, that does not look good. 1/2 y, what am I doing? 1 over y. That's not what I want. 1/2 y squared, or you could write y squared over 2, plus some constant. And then on the right, we also have 1/2 x squared plus some constant. And again, this constant on the left, we're going to subtract over to the right. I mean, this constant could have been negative, so we could be adding it to the right. But either way, we want our constant to be on the right. And it doesn't just cancel out because it could be anything. So we're just going to write plus c on the right. Okay, now to isolate the y, we need to first, before we square root, we want to multiply both sides by 2. So that's going to cancel out the 1/2. And we're going to have 2 times this whole thing. So that's going to be, I'm just going to write it like this with parentheses first to show that we're distributing to both of these. So that's the constant. 2 times 1/2 just cancels out, so we get x squared. And then, I mean, it's not necessary to write 2c because this constant could be anything and we're just doubling it. So really it's just another constant over here plus some constant. And now the last step is to square root both sides. So y equals, and now it does matter. This constant is stuck inside of the square root, and so we must leave it inside there. And so that's called the general solution. So c could be anything. And this function, when we plug it back into the original, we would say dy dx, so the derivative of y would be some function x over square root of x squared plus c. Okay, that is, the derivative is going to look like that with some constant in there for c instead. That's what we're finding here. And so to find the general solution, it says y of 0 is 1. So y is 1 when x is 0. And so we get the square root of 0 squared plus c. And now to solve for c, we would square both sides. So 1 squared equals c. So c just equals 1. Okay, so the particular solution would be x over square root of x squared plus 1. That would be our particular solution to the differential equation. So yeah, we're plugging this. So this is still dy dx is this whole fraction, and the y is just on the bottom. Y equals square root of x squared plus 1. Okay, so then I'll do one more example with you. This one gets even more complicated, and there's a little bit more notation going on here. So sometimes they get lazy and they just write y prime, and that's the same thing as dy dx. So the first thing I want to do is rewrite this as dy dx. And then we've got 3x squared times y squared. So again, separate the variables by multiplying both sides by dx. So we have 3x squared times y squared times dx. And then this time we have to divide both sides by y squared to get the y on the other side. So we have dy over y squared equals 3x squared times dx. Okay, and now there's a better way to write this. This is really 1 over y squared times dy. Okay, and now we get to the point where we can integrate both sides. So I'll put my integral in there. Okay, and now to integrate, remember we always want to solve for y. So if we're going to integrate 1 over y squared, that means y, the power is -2. So maybe we'll rewrite that as y to the -2 when we're doing our antiderivative. And I'll just rewrite this side 3x squared dx. So antiderivative of y to the -2 is negative y to the -1, because we have to add, I have to do 1 over n plus 1. So 1 over -1 is just -1. And then -2 plus 1 is -1. Plus some constant c, but we're just going to move that over to the right. And then here we have to do 3 times 1/3 x cubed. So this antiderivative is just x cubed plus some constant. It doesn't look like a c. Okay, now we should multiply both sides by -1 to get rid of this negative. We still have y to the -1. So now this is going to be negative x cubed. And you could say minus c, but it really doesn't matter. If c is a negative number, we can still add it. So it's still just plus c. And now to flip this, y to the -1 is really 1 over y. So we have to solve for y, we have to flip the entire other side. So negative x cubed becomes -1 over x cubed. Actually, we need to flip the entire side. So think of this as all over 1. We need to flip the entire thing. So that plus c is going to go on the bottom. And the whole thing is negative. So that's how it's called reciprocating both sides. Find the reciprocal of both sides. So that's our general solution. And then to find the particular solution, use the initial condition here. -1 equals, and then we plug in 1 for x, so we get 1 cubed, which is just 1, plus c. Now to solve this, you could kind of think of this as a 1 over 1, and then cross multiply. That's probably the best way. So 1 times -1 is -1, and then we set that equal to -1 times 1 plus c, which would be -1 minus c. So then we add 1 to both sides and we get 0 equals minus c, so that means c equals 0 in this case. So then our particular solution is y equals -1 over x cubed. Okay, and that, again, that means, going back to our original equation, y prime, that's the derivative. If we plug in our function for y, we get 3x squared, and then it says y squared, but y is -1 over x cubed. So we would get, if we square this whole function, we get 1 over, and then, so let's just write this out. If I'm going to square this whole thing, parentheses squared, you just distribute the 2 to both. So the top's going to be +1, the bottom's going to be x cubed times x cubed. We just add the exponents. So we get x to the 6th. X to the 6th. Okay, and we could simplify this even further. This would be 3x squared over x to the 6th, which would just be 3 over x cubed. Okay, so that it turns out that our derivative is going to be always in this form, 3 over x cubed. Yeah, so the answer to a differential equation is another function itself. And eventually we'll look at what these graphs are telling us and a little bit more about what differential equations can do. So what I want you to do is work out the next 3, or the next 4, 5, 6, and 7. Do them on separate paper. Number 7's pretty difficult. I gave you a hint there. You must use substitution when you integrate this function. So let me know if you have any questions as you're working through these. I'll be here. You can email me, send me a message, and we can work through it. Bye.